Welcome students. We have already gone through the exercise 1.3 with the question number 1 and 2. Let's begin the question number 3. That is all about to express the following in the form of P upon Q, where P and Q are not equals to 0. So let's start the first question to understand actually what is it. Here the first question is 0.6 bar. It means the 6 bar, it means the 6 is repeating number of times till infinity. So let us start this question. 0.6 bar. We'll consider let x equals to 0.6 bar, where this 6 bar, it means we're going to repeat this 6 number of times, and we're keeping here that dot dot dot, it means it's repeating. Now since only a single digit 6 is repeating, we're going to multiply 10 on both the side of x and 0.6666. On doing so, this x will become 10x, and this 0.66666 into 10 will becomes 6.66666. Now we're going to differentiate this 6.66666 into 6 plus 0.666666. If we add these two numbers, we will get 6.6666. Now, this 10x, I'll copy down as it is. This x is as it is. Now, in place of 0.66666, we're going to write the x, because the value of x is given here 0.66666. So now, we're going to bring this x next hand side. So it becomes minus x, 10x minus x. This will on further simplify give you 9x equals to 6. So x equals to 6 upon 9. It gives you 2 upon 3. I hope you understood. Similarly, we have 0.47 bar. So here the bar is over the 7. So 7 is repeating again and again. Now since a single digit is repeating, we're going to multiply 10 on both the sides. So it becomes 10x. And on doing so, multiplying 10 with this 0.477, this point will shift one more place ahead. It becomes what? 4.77777. Again, multiplying 10 on both the side will give you what? This 10 into 10 will give you 100x. And this 4.777 multiplied by 10 will give you 47.77777. Now this 10 as it is. 47.777 is differentiated into 43 plus 4.777. This 100x as it is. 43 as it is. 4.777 we will write as 10x, because we know the value of 10x is here 4.777. So we'll write 10x. Bring this 10x to next hand side, becomes what? 100x minus 10x will give you 99x equals to 43. So x equals to 43 upon 90. I hope you understood. You can try this third one, and if you don't know, I'll make you understand once the class will start. Let's come to the next question. Question number 4, 0.9999, and represent it as a P upon Q form. So since the single digit is repeating again, we're going to multiply 10 on both the sides. So before that we do, let's start the question by assuming x equals to 0.9999. Since single digit is repeating, multiplying 10 both the sides, so it becomes 10x, and 9.9999 will becomes 9.9999. Differentiating this number as 9 plus 0.9999. In place of 0.999 we will write it x, because we have already above the value of x equals to 0.99999. So we did that. We brought this x to next hand side, become 10x minus x equals to 9. So 10x minus x will be 9x equals to 9. So x equals to 9 upon 9 will gives you 1. I hope you understand. Let's go with the question number 5. Here they are asking us to tell us what are the maximum number of the digits be repeating digits in the decimal expansion of 1 upon 17. It means it simply tells us that on dividing 1 by 17, so after how many digits the numbers is going to be repeated in the coefficient, that we have to show. So for us, simply you have to divide, and on dividing you will finally see after 16 digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and finally 16. So after 60 digits, again these all numbers is going to be repeat on dividing 1 by 17. Let's come to question number 7. Here it says, here these are the rational numbers, and the decimal expansion of all these rational numbers are terminating. So what is the property of Q in this question? What the property of Q test process that we have to show? Here the 5, 10, 2, 8. So here the prime factor is 5. Here is 2 into 5 for this. 2 into 5. We have again here 2 single, and here we have 8. It means 2 into 2 into 2. So we seen here is 5, here is simply 2 into 5, here is simply 2, and here is 8. This is 2 into 2 into 2. So the denominator of all rational numbers are in the form of 2 into 5. Means the value of Q. This is the value of Q in denominator. It should be in the form of 2 into 5. Then that such rational numbers will always have the terminating decimal expansion. Terminating decimal presentation or expansion. Let's come to question number 7. Write 3 numbers whose decimal expansion are non-terminating, non-repeating. So it's asking about irrational numbers. So the first one, we have several examples. So here it is shown that 0.41, 411, 4111, 4 times 1, 4 5 times 1 means the numbers are not repeating here. Here the 1 is repeating in consecutive manner, means 1 time 1 is there, here 2 times 2 is there, here 3 times 1 is there, here 4 times 1 is there. It is irrational number. Another example, 2.01, 001, 0001, 4 times 01 is again another example of irrational number. And finally the pi, we itself know that pi is irrational. This is the third example. Let's come to question number 8. We have to show the 3 different irrational numbers between these 2 rational numbers. So on dividing 5 upon 7, we get this is non-terminating repeating. It means it is rational. And 9 upon 11 means on dividing 9 by 11, again we getting non-terminating repeating numbers, means 81, 81, 81. That's why it's repeating. Therefore it is kept here bar. And here is 0.74285 is again repeating after 68 numbers. So between these two, we can write simply these 3 ways of irrational numbers. 7, 1 is there. We'll start with 7, 2, 7, 2, 7, 2, 2, 7, 2, 2, 7, 4 times 2. After 2, we'll write 3, 7, 3, 7, 3, 7, 4 times 3, like that, so on. Then after 3, we'll write 4, 7, 4, 7, 4, 7, 4, 4, 7, 4 times 4. So these are the several ways we can write the 3 irrational numbers between given 2 rational numbers 5 upon 7 and 9 upon 11. Let's go to question number 9, that is about telling us the rational or irrational that we have to identify. The first is root 23, since it is not a perfect square, therefore it is irrational. 225 is a perfect square number, therefore it is rational. 0.3796 is terminating number. It is terminating, therefore it is rational. 7 0.478478 is repeating again, it is rational, and this finally 1.010010001 4 times 0, therefore it is irrational number. These the numbers are not repeating here. I hope you understood.